Hi everyone, welcome back to my channel. So today we'll be looking at polar coordinates, especially the calculus part. So it involves finding the maximums, okay, where we do the differentiation, and also finding the areas, okay, where we have to do lots of the integration. So as we can see, the integration and the differentiation that is usually involved here is not easy, okay. So that we have chosen some questions that is after May June 2020 for us to look at an efficient way for us to deal with those kind of the questions here. All right, let's get started. Let's look at this first question here. So it's coming from winter 20, okay, paper 1113, question 7. So those part that is without the calculus, I will just skip that already. Yeah, so we will focus on just to look at like those calculus part. Okay, so we look at the part D for this question here. So using this identity given here, okay, sine 4 theta, that is given as that, all right? And we want to find the maximum distance of C from the line, which is theta that is equals to half pi. Give your answer correct to 2 decimal places. Now, so to give us a little bit of the context, what do they mean by the maximum distance from the line, okay, which is theta that is equals to half pi here. So basically, this is our y-axis, right? So when we want to look at, okay, now, let's say the curve, okay, let's say the curve looks like this, okay? There is certainly one point that is actually furthest from our y-axis, right? So how do we look at this distance? Here is our x, okay? It is actually our x here. So in other words, what we want to find here is the maximum x, okay? So when we want to look at the maximum x here, we are looking at dx d theta that is equals to 0, right? So for our dx d theta here, how do we start is, okay, we will have to do x that is equals to r cos theta. Okay, in order for us to differentiate that, we substitute the r from the question given. So that would be a sine 4 theta cos theta. Okay, so next step here. We can, of course, okay, differentiate from here already because it seems like it is much more easier for us to differentiate from here, right? So let's say if you actually try to differentiate from here, somehow you realize that, okay, in some like terms later, you get cos 4 theta, right? So getting a cos 4 theta is actually really a pain here because you do not know what is the identity for the cos 4 theta. So it's really difficult for us to solve the equation later, okay, as we let the dx theta to be 0, okay? So we do not want to have this one. So this is why the identity is given right away here. So we can already, okay, substitute that identity into the sine 4 theta that we have here, okay? So after we substitute this identity into the sine 4 theta, and after we multiply that by the cos theta, so we will get 4 sine theta cos power 4 theta minus 4 sine power 3 theta cos square theta. Okay, so differentiating, sorry, this is not the x d theta yet, it is still x. Okay, so now we can really start differentiating it already. So that's where we actually look at the dx d theta. Okay, so this one we do not have a choice, okay, but we will just have to use product rule on each term. Okay, so to use a product rule on each term, okay, so first we differentiate the 4 sine. Okay, we differentiate the 4 sine, so we get a 4 cos theta. Then we keep the cos power 4 theta there. Then later, we differentiate the cos power 4 theta here. So we keep the 4 sine theta. So when we want to differentiate the cos power 4 theta, it gives us 4 cos power 3 theta, and then differentiate the cos theta itself. Yeah, so that's where we get negative sine theta for that. So done for the first term. Now we want to look at the second term here. So the second term that we have here, okay, is negative 4 sine cube. So let's say we differentiate the negative 4 sine cube, okay, that's where we get negative 12 sine squared theta. Of course, we need to differentiate the cos itself, okay, times the cos squared theta. And the next one is to keep the negative 4 sine power 3 theta, and then we differentiate the cos squared theta. So that's where we get 2 cos theta. And of course, remember to multiply by the sine theta, negative sine theta. Yeah, so this is when we differentiate the cos theta. Okay, so we get negative sine theta there. So good thing, okay, we have got everything differentiated. So we tidy up a little bit from there. Okay, so that's where we get this expression here. So we get 16 cos power 3 theta sine squared theta. The next that we get minus 12 cos cube theta sine squared theta, and then the next one is a positive, okay, 8 sine power 4 theta, and also we've got the cos theta here. Okay, so now we just tidy the things up because the second and the third term, okay, can be added together. So that's why we get like a 4 cos power 5 theta minus 28 cos power 3 theta, and then sine squared theta plus 8. Okay, we've got sine power 4 theta cos theta. Okay, so at this stage, we can already let the dx theta to be 0. They are actually quite nice already. Okay, so dx theta is equal to 0, which will give us this expression that we have so far here, right? We realize that, okay, if we let it to be 0, we can cancel off all the 4, okay, from all the terms. And also at the same time, we can factorize the cos theta out. So let's say if we factorize the cos theta out there, right? So we have cos power 4 theta minus 7. This is a cos squared theta sine squared theta plus 2 sine power 4 theta is equals to 0. Okay, so now of course we are trying to solve for the cos theta, right? And also we have got another polynomial, okay, that we see that is power 4, like cos power 4 and also the sine power 4, okay? So in this case, we are not considering the cos theta that is equals to 0, because if we solve that, it gives us pi over 2 for the theta, which is not what we are interested in, right? So we're not interested about that. So we do not want to look at that anymore. And this is apparently a requirement in the mark scheme. So mark scheme specifically mentioned that we must mention, okay, we are not considering the cos theta. Okay, so you can see something here like, okay, we don't want to look at the cos theta. Okay, so mention cos theta equals to 0 at this stage here. Okay, so okay, after that, what we will get from that, okay, let us just tidy up this one a little bit, write it in this form perhaps. Yeah, so we just switch, okay, all the terms here. Okay, so you see that you have got all the sine power 4, cos power 4 and things like that. So they are all having even powers, right? One thing that we can do is we can either change it all to cos or change it all to sine. Okay, we will somehow get some quadratic equation that is in like cos or sine. Okay, another way that we can consider doing here is that instead of changing all the sine and the cos to like either sine or cos, okay, like what we usually do when we see this kind of expression, one convenient approach, okay, for us to do here is we try to divide that by a cos power 4 theta. So when we divide by the cos power 4 theta here, right, we are getting a quadratic that is in terms of the tangent square. Okay, we will get a quadratic that is in terms of the tangent square here. All right, so then, okay, we will just have to factorize this one, but unfortunately, we won't get a nice answer. Okay, we can't factorize that. So that is where we use the quadratic formula, okay, to find out what is the value of that. So if you look at the quadratic formula here, so we're actually solving for tangent square theta. Okay, so tangent square theta is minus b plus minus. So I have got b squared minus 4a, b 4ac divided by the 2a, right? So for this, we're actually having like 7 plus minus, so inside there it is 41 over 4. Okay, so these are the values that we have for the tangent squared theta. Okay, so here, okay, we need to, of course, take the square root, okay, of those 7 plus and minus square root of 41 over 4, right? So when we actually take the square roots from there, right? So there are many cases that we want to consider here. Okay, so let's just move to the next page before we like write down, okay, all the solutions here. It's actually quite a bit, yeah. Okay, so we continue from what we have just now. Okay, let's just write down our results here first. So we have got tangent squared theta. It's either 7 minus 41 over 4, or okay, we could have the tangent squared theta is 7 plus 41 over 4, which, okay, we really take the square root, okay, of the value there. So from now on, because you can see the question just asks us to give in decimal place, right, for the answer. So we won't, so please do not expect to work with like nice value from here anymore, okay? So anyway, okay, we will have the two values for the tangent theta here. Okay, so for this value of our theta here, right, tangent theta here, so for this, we have got 0.63863. Okay, so although we know that it should be having plus minus for this value here, like 0.3863. Okay, but if you do not want to write out the negative, okay, what is the reason here before that? So in the question, okay, let's look at the question. The value of the theta that is actually being given here, right, is only from 0 to 1 over 4 pi. Okay, so you can actually mention that here we are only taking the positive value of the tangent theta because it is only from 0 to 1 over 4 pi for this theta here. Okay, or else the mark scheme actually expect us to write the plus minus. Okay, so when we actually try to solve all the values, everything here, try to solve the equation here, be clear, okay? It's better that we write more, then later we explain why we're not taking certain values. Okay, we better write more first. We do not always assume that examiner knows what we know, right? So if we know something, we want to do something, we explain clearly, yeah? Okay, anyway, so we already have this value of the theta here, and we try to solve, okay, this value of our theta here. So this value of the theta, when we actually try to solve, okay, we actually get 0.3686. Okay, so you can see the value is very similar, okay, to the tangent theta here. So just be more careful about it, right? So same thing, okay, that we want to look at for this one. So we have got the tangent theta here, okay, is we're actually getting, this is 1.8305, right? So again, we only want to take the positive because the theta is from 0 to 1 over 4 pi. So here we have got the theta. Okay, so when we try to solve the theta here, 1.0708. So we are going to reject this one. Again, what is the reason? This is already more than 1 over 4 pi, okay? So what is the value of the 1 over 4 pi is actually 0.7 something. Okay, so this is already more than 1 over 4 pi there. So because of this, okay, we are going to just take the theta, which is we have 0.3686 here for our theta, and do not forget, okay, what the question actually asks us to find here. They need us to find, okay, really find that maximum distance. So what is this maximum distance again? It's actually our x. Okay, they're actually looking for the x here. So make sure we substitute this value. Okay, so x that is equal to sine 4 theta and cos theta. Then, of course, we have to use our calculator to evaluate it. So the value that we have here is 0.9285. But before we actually, before we actually give it into decimal, okay, we can actually write more decimal places first. Then at the end of the day, only we measure that, okay, so this is the final answer for the x, okay, which is 0.93. rounded to 2 decimal places here. Okay, so that's how we look at the first question here. Okay, so we can move on to look at the next one. All right, next one, coming from Winter 20 again, paper 1-2, okay? So this is polar questions, okay? We'll be looking at part B and part C, okay? Both of them are slightly challenging. For part B, so we are supposed to use a substitution, okay? And then we want to look at the area enclosed by this region, okay? By this region and enclosed by the sea and the initial line. So basically, I will skip, okay, about like why, what are the limits that we use, okay? We just look at the integration here right away. All right, so we know that for the area here, okay, it's actually half integrate r square d theta, okay? The limits, okay, we know that it's from 0 to pi, okay? I'll skip those explanation here. We are focusing on the integration part. R square, okay, so you have to be careful. It's ln 1 plus pi minus a theta squared, okay? You have to be careful. The square belongs to the ln, not just the 1 plus pi minus a theta there, okay? So what you are actually looking at here is this whole thing, square d theta here, when you try to integrate from there. Yeah. Okay, so substitution is given is quite nice. Yeah, so we will actually proceed to look at like now. If we have the u that is 1 plus pi minus a theta, so obviously our du d theta is just -1. So the du is negative d theta, or the negative du is our d theta, that we can replace that later. And if we are using the substitution here, remember to change the value as well. So earlier on, we have all the theta, right? So the theta for the limits, theta equals to 0. So we have to find out what is that u, 1 plus pi. And then when the theta is pi, we have the u that is equals to 1. Okay, now we can actually do the substitution to this, okay, integral here already. So that's why we get half integrate. So see, we are not changing everything to the u already. So 1 plus pi, 1. So this is a dangerous part here. Do not always assume the lower limit is always having the smaller value. Okay, in the substitution, the value has to correspond. So you can see what happened here is that when the theta is a 0, okay, the u here is 1 plus pi. So the 1 plus pi should be at the lower limit there. Okay, the value must correspond. Yeah, so like I said, the assumption of saying that the lower value, the smaller value is always at the lower limit is wrong. Okay, so this is one thing, okay, that we need to be careful as we do the substitution. Okay, so moving on from here, yeah, So we're actually looking at like now, this is a ln u, the whole thing squared. Okay, d theta, so d theta, we actually have it like this result here. So the d theta is a -1 du. Okay, so -1 du. In the next step, because I know that if I have a negative in an integral, I can switch the upper and also the lower limit here. Okay, so the result, we will actually have just a half, and then we want to integrate 1 to 1 plus pi ln u squared du for our integration here. Now, we have to do the integration from here, okay, whereby this, okay, is to use the by parts, okay. There's no other way for us to do already, since we have already done the substitution, yeah. So it is to do the by parts in this case. So by parts is very easy, nothing much for us. Oh, okay, so in this case, in by parts, we have got the u and the v, right? Which will confuse ourselves, okay, because here we are integrating with respect to the u. So to avoid any confusion, just replace our usual u and dv dx by other thing, okay? So let's say we use the p and also the q here. So let's say the p that we have here is ln u squared. Okay, so dp du is our 2 ln u over a u. Okay, this one we know how to differentiate from there. And then another one is our usual dv dx, right? But since we actually want to change that, so let's say we use the dq du. Okay, so the u and v that we usually use in the by part, I change that with the p and q to avoid confusion. So we do not have any other like a dq du here. It's a 1. So as we integrate, we know that it is a 1, it is a u, sorry. Okay, it is a u here. Now, let's put everything, okay, back to the integral here. So the clue that we want to be careful here is that all the negatives and really put lots of bracket to that. Okay, parenthesis is very important when we deal with like so many like the positive and the negative signs here, right? So what we have from there, okay, probably we need a new page here. Okay, let's go to the next page. Okay, so this area is half. Okay, and then we will see, okay, the first one is uv that we need to evaluate. Okay, so the uv here is like our pq, okay, p times q, so we get u times ln u, the whole thing squared, to be evaluated at 1 and 1 plus pi, okay, minus integration of the 1 to a 1 plus pi, okay, v du dx, so usually is this, okay, that is multiplied together. So basically we are integrating 2 ln u over u times u. Okay, I'll just write the whole step here for clarity. Du, close the bracket. Okay, so remember we have got lots of the brackets that we want to use here to avoid any types of the confusion that we have, right? So half, okay, and then we open this bracket here. You can keep this to the very last stage, only you evaluate, okay, but for me I would have evaluated that already, okay, because what happened here is that we will only have 1 plus pi. When we sub into the u, we have 1 plus pi ln of the 1 plus pi, okay, the whole thing squared, so I put a squared for that, minus when we sub the 1 into the u, so we know that ln 1 is actually a 0. Okay, so I will just not write that substitution, then I will know that it is just a 0 purely, right? Then for this, we actually have the u cancels off, so we only have 2 ln u. So let's say we put the 2 outside there, we are just integrating a ln u du. Okay, so we have got half. This is 1 plus pi. Okay, everything is as usual here. Okay, put more bracket for that. Okay, so to integrate the ln u here, so to integrate ln u, you can use by parts again, but if some of us are already familiar with the result in our head, okay, we can just use that right away. So integrating a ln u gives us u ln u minus u, okay? So that's what I mean by u ln u, sorry, u ln u minus a u. Okay, so now let's just tidy up a little bit for the second term there. So that is 2, okay, and then we have got to substitute the values very carefully here, yeah? 1 plus pi ln 1 plus pi minus 1 plus pi. Okay, I do not have enough space, okay, allow me to just continue at the second line here. Minus, okay, so I don't want to put another bracket here already, so I just like minus it right away. So this is minus ln 1, which is a 0, minus a negative u, yeah, so we have a plus u, which we get a plus 1 here, okay, so you know what I mean from there. I'm just using less of the bracket there. So the clue, or why do we actually find this kind of the question very complicated, is that it is really a lot of the terms that we want to evaluate here, okay? So if you are not sure on the evaluation and things like that, make sure we just put more bracket to that, okay? So let's just simplify, okay, whatever that we have inside the bracket there. I think we can use the square bracket now already. So you can see when I also when I try to do these questions, right, I'm also being extra careful here. Okay, I will have to recognize which terms are multiplied together and which belongs to which and things like that. Okay, so we have to be very careful. Okay, so what do we have for this? Okay, I have to use another bracket here. So 1 plus pi, and then ln 1 plus pi. Okay, so just tidy up minus 1 1 plus pi plus a 1. So only gives us a minus pi here. All right, so perhaps here we can already expand the last term there, okay? So the key thing is to do it very carefully and patiently, okay? So minus 2, okay, finally we are there. Ln 1 plus pi plus 2 pi. All right, then we can try to expand if we want. Okay, but looking at what we have in the questions, right, the last term is actually isolated, but the first one is still in a half there. So why not? Okay, why not we just expand only the last term there? So we will keep, okay, whatever that is in the first two terms in the bracket of the half there. So also another tips, okay, to work with this kind of the expression here is as you try to work on that, do not just indulge in whatever that you are trying to work on. You have to always refer back to what the question needs, okay, the expression that the question needs. Then only you can see, okay, where's my progress? Am I actually heading to the correct direction? What are the strategies that we can actually apply, okay, from there? All right, so just look at the two terms inside the bracket here. So you notice that there are some common terms that we can actually factorize out, okay, namely 1 plus pi, and also we've got ln 1 plus pi that we can factorize. So inside there, okay, so once we factorize these two terms out, we still have one of the ln 1 plus pi, okay, and then we have this is a minus 2. Okay, and let's see. So you see, this is exactly what the question wants us to prove. Yeah, so this is our result at the end of the day. All right, now we will look at like the part C here. Part C is, okay, show that at a point C furthest from the initial line, okay, we have got this equation 1 plus pi minus theta and so on equals to 0, and verify this root has this has a root in between 1.2 and also 1.3. This is to actually look at the dy d theta that is equals to 0. So this is a maximum y. Okay, so for this part C here, okay, we have got the original r here is actually ln of the 1 plus pi minus theta. So we want to actually look at dy d theta that is equals to 0 later on. So this is very easy. We will start out with like the y that is equals to r sine theta. Okay, so nothing much. Okay, nothing much, very easy for us to differentiate. We just have to consider the product rule. Okay, so let's say we differentiate the ln. Okay, then be careful. We have to differentiate the 1 plus pi minus the theta and put it in the numerator, right? This is a negative one, not just a 1. Yeah, be very careful about it. Sine theta, and then plus ln 1 plus pi minus theta. Differentiate the sign, that's where we get a cos theta. Now we just let the dy d theta that is equals to 0, which will give us 1 over 1 plus pi minus theta sine theta equals to ln 1 plus pi minus theta cos theta. Okay, so let's see what do we want in the question. Okay, everything is at the numerator. So here we just do a little bit of like rearranging here. So we have sine theta over cos theta that is equals to 1 plus pi minus theta and then ln 1 plus pi minus theta. This is a tangent theta, obviously. So basically, the work other than is just rearranging, yeah, to get the equation. So yeah, proven. So what about the last part where they actually ask us to verify that it has a root, okay, in between like 1.2 and 1.3. So this is just to use the sign change rule, okay, that we have learned in the pure free. Okay, so use this method to actually prove that, yeah, there's just one mark which this part of the question will carry. Okay, so we won't actually do that already for this one. Okay. Alrighty, so let's look at the next question. Recently, there are many more very interesting questions which is coming, yeah, out. So we have to be really aware of what we do, okay? How do we actually integrate and things like that, okay? So very interesting equation here where we are looking at like r squared, that is an arctangent of the half theta. So we will skip again all the sketching part. We are just looking at the calculus part. So we're just looking at the part B and the C here. Part B is that now we have got the area. So area is looks very easy, okay? Because this is just a integrate half r square, right? So the area here is just half integrate the r square. So the theta is from 0 to 2. So the r square is already given nicely. Tangent, arctangent, half theta, d theta. Okay, so do not continue from here by saying that, okay, after we integrate, we get 1 over 1 plus whatever square, right? No, this is integration. So how do we actually integrate an arctangent function? Okay, this is also some specific knowledge that we need to know here. We have to use by parts. Okay, we do not have any other way other than by parts here. Okay, so very obviously, the u is like the arctangent here. That's the only thing that we can differentiate from that. So our dv d theta must be a 1 already. So obviously, we have got the v is theta. Okay, so how do we apply the results of differentiating an arctangent of the x here? Sorry, 1 over 2 theta here. So the du d theta here is, okay, the clue is 1 over, if it is x itself, is 1 plus x squared here, right? But now it is something else, it's a half theta. But still, we substitute the half theta into the x itself in a formula and then differentiate the half theta to multiply. Okay, this is the chain rule. Okay, this is a chain rule here. And then, okay, what we will get at the end of the day when we tidy up and expand everything. Okay, I'll just skip the step there. Yeah. So we're actually getting this. Now we can integrate already. So half, we have got uv. Okay, I use a bracket again. So uv is theta times arctangent of a half theta. Okay, minus integration of the v du dx. Okay, so we'll evaluate the first one. So half, this is 2 arctangent of the 1 minus a 0. Okay, this is nice. And then minus, okay, so this is 2 theta over 4 plus theta square. So this is the f prime x over fx form. Exactly this form, okay? So because we differentiate the 4 plus theta square, that will give us a 2 theta there. So when we integrate this one, okay, we know that we're actually getting a ln of the 4 plus theta square from there. Okay, but remember we have to evaluate it at 2 and 0. Okay, so for this, we have got 2 arctangent of the 1. Arctangent of the 1 gives us 1 over 4 pi. Okay, minus, okay, we just have to evaluate this thing here. So this is a ln 8 minus a ln 4. And we're done. So this is half. And then in a bracket, we have got 1 over 2 pi minus a ln 2. So ln 8 minus ln 4 means ln 8 over 4, okay, for this one. So we get a ln 2. So this is a result, yeah, very simple. Integration, okay, that we need to consider here, okay, is to use by parts. Okay, now let us look at the part C now. Show that, okay, at the point that is furthest from the half line, theta equals to 1 over 2 pi. Okay, so we know we are going to do, this is the dx d theta, yeah, and we will actually get this result here and verify that this equation has a root that is in between 0.6 and 0.7. Okay, so if you actually see that here, we have got a r square, right? So in the process of our finding the dx theta, okay, let us look at the next one. So this is our r square. And previously, what we have actually done like a lot, okay, is that now the x is equal to r cos theta. And when you think of, okay, you want to substitute this arctangent half theta with a square root inside here, that is very painful. Imagine you need to differentiate the arctangent that is with a square root. This is very painful to do. Okay, so here we can actually make use of a slightly different technique to simplify our working a lot. Yeah. So before we look at the x is equal to r cos theta, we do a bit of the prep work. Okay, let's differentiate this r squared with respect to the theta first. Okay, we will see the reason later. Okay, by the way, so the right hand side, we already have got the earlier result that we have done this in the by parts. This is our result. So for the left hand side, it's to differentiate r squared but with respect to the theta. So this is implicit differentiation. Yeah, so for implicit differentiation, we are getting 2r dr d theta. All right, so of course, there's 2 that we can actually cancel conveniently. So this is the result that we get for r dr d theta. Okay, why do we need this? Okay, let's see here. So now we have got the x is equal to r cos theta. Okay, instead of substituting the r here and we start differentiating, we differentiate when the r is there. So what do we mean by that one is we have got the dx d theta, right? So because r is a function of the theta, okay? So if we try to differentiate the r here, right, we need to use the product rule, right? So the product rule says that we differentiate r, which you get the r d theta, fix the cos theta, plus r, and then we differentiate the cos theta, then we get a minus sine theta. So finally, okay, we'll have dr d theta cos theta minus r sine theta. So in a later process, okay, we need to use a dx d theta that is equal to 0, right? So that means we are actually working with r sine theta that is equals to dr d theta cos theta. Okay, so the next step is very important, okay? We multiply the whole equation with an r. The reason is when we multiply the whole equation with the r here, right, all the expressions that we have found earlier is there. R square is just coming from our equation of the polar curve. R dr d theta is also something that we have found earlier. So you can see, okay, the top of this page here. So we already have like r dr d theta. So everything is conveniently there for us. Okay, so for the r square, that's our arctangent of the half theta. Okay, and then let's see what the question wants here. Okay, so we just keep the sign there perhaps, equals to, so r dr d theta is actually our 1 over 4 plus theta square cos theta. Okay, so this is very nice here, whereby we just have to do a little bit of the rearrangement. Okay, let's see what the question wants us to do again. Yeah, so just bring the 4 plus theta square over there to multiply, move the cos theta over there. So everything is done in such a easy way. So do not struggle. I mean, we don't need to struggle about like how to differentiate the expression which is in the square root. That's very painful. Yeah. So whenever we see the equation that has r square and they ask for this kind of the maximum distance from the initial line or the theta is equal to half pi, right? Use this kind of the method. Okay, so proven, hence, and then for the last part, verify this is the sign change rule again. Yeah, so we won't actually go through this one anymore. Okay, all right. There's a few more questions here. Okay, so this is quite an interesting question as well. So we'll just focus on a part C, okay? Part C, it is to show that the area, whatever, okay? So we should be able to like get this, yeah, very easily. We will just focus on how to integrate this, yeah? I'll show you the method to do that. Okay, so because it is given that we have got the t is equals to tangent theta, right? So we just differentiate from that. T is equals to tangent theta. So we have dt is equals to secant square theta d theta, and you can see the top there is actually having 1 plus tangent square, right? And knowing that secant square is actually 1 plus tangent square. So you'll see this 1 plus tangent square d theta, right, is at this whole thing here. So this whole thing here later on, it can be replaced by the dt already. Okay, it's actually very nice here. But before we actually do the substitution, the limits, okay, we also need to change that to the t, yeah, because we are having the values of the theta now. So theta equals to 0, t is a 0, theta equals to 1 over 4 pi, the t is 1. So we actually get a very nice value from that. So the whole thing, okay, so the area that we're looking at here is half a. So we just do the substitution right away, yeah. So dt is the whole thing that we actually circled here that you can see. Yeah, so the top, okay, the numerator is only having a 1 now. So this is 1 plus t plus a t squared here. Okay, so when you start thinking about this, okay, oh, are we doing like partial fraction? Are we doing ln? Okay, no, okay, because we can't factorize it. And we can't do ln either because there's no linear expression there's no 2t plus 1 in the numerator. It's just purely a 1 in the numerator there. So the only way that we can actually make use of, okay, to actually integrate this is we are getting some sort of the arctangent later on. Okay, so to obtain that kind of the result, okay, sorry, the limit is 0 to 1. So to obtain that kind of the result, we got to do completing the square. This is what we get when we do the completing the square. And then we have to sort of like look at it in a form of like a t plus half square plus, so this is 3 over 4. It also has to be written in a form of the square. Okay, so the result that we are referring to here is if we integrate 1 over x squared plus a squared, we should have 1 over a arctangent of the x over a. Okay, so whenever we see like this squared term here, right, the t plus half, okay, it is replaceable with this this x here. Okay, as long as it is a linear inside, yeah, and the t here do not have any other coefficient here, then we can actually use this result right away here. Okay, so if we actually use the result, so we get half a, and then this is our a here, so we need to divide, so times 1 over 3 over 2. The result is, okay, arctangent of x, this is our t plus half as our x in a formula, over the a in our formula. So we just tidy up a little bit, so we get 1 over 3a. Basically, this is an arctangent of 2t plus 1 over a third 3 evaluated at 1 and 0. Therefore, we are actually having 1 over third 3a, and then this is a arctangent of when we substitute t equals to 1, we get a third 3 minus, this is 1 over sec3 for the arctangent, which, so this gives us a pi over 3. Another term here gives us a pi over 6. So when we actually tidy up and things like that, we should be getting this result here. Okay, it's actually quite a nice result. Okay, so as you can see, the skills or the requirement of the integration is getting more and more demanding. So we really have to make sure we have a very good integration skill, yeah, to be able to recognize different types of the functions and things like that. Yeah, it's very important. Okay, let's move on to look at the next question, which is also the last question of our video. So by now, we should be very familiar with different techniques and tricks, okay, that we will use to answer the questions here already. Okay, so this is coming from Winter 22, okay, paper 1113. We will only focus on the last part because all the rest are quite easy, okay, to do. Even for the area, it's also like it's in R square already. Yeah, it's very easy. So we won't actually look at that. So just look at the part D here. So the maximum distance, okay, of a point on C from the initial line, we want to give the answer in the exact form. Okay, so again, it is to look at the distance from the initial line, and it's a maximum. That is actually to look at the maximum y here. Okay, so we have to look at like y that is equals to r sine theta later on, but we are not going to look at this first. So remember when we see the equation here that is having like r square in terms of something else, right? We do the prep, okay, by differentiating it with respect to the theta first. All right, so that it's we're getting a 2r dr d theta that is equals to negative 72 sine 2 theta. So if you want to tidy that up a little bit, feel free. So this is a result for our r dr d theta. Now we can start looking at the y. Okay, y is a r sine theta. So again, we differentiate that with respect to the theta right away. So the r, when we differentiate, we get dr d theta, keep the sine theta, product rule, okay, plus r, we differentiate the sine, that's where we get a cos theta there. Now, we can let the dy d theta to be 0. Okay, so that we get dr d theta sine theta plus r cos theta equals to 0. Trick is to multiply by r here. Then we can substitute, okay, what we have, okay, for the r dr d theta at the top of this page here. Okay, so this is what we have. R square is 36 cos 2 theta. Cos theta equals to 0. So since it is equals to 0, right, we can actually just cancel out the 36 and we do a little bit of the rearranging. And we are happy, okay, we are so happy to see this expression here. This is our cos of the A plus B. Cos A cos B minus sin A sin B, our compound angle formula. Basically, this is just a cos 3 theta that is equals to 0. And we can actually solve for the 3 theta here. So the only solution that we want to take here is pi over 2. If we are actually not giving full solution and things like that, right, you always have to mention, yeah. So because the theta here is only from 1 over 4 pi to negative 1 over 4 pi from the question, you need to mention this one so that we are only taking the solution that is pi over 2 for 3 theta. So therefore, the theta here is a pi over 6. So again, because they are looking at this maximum distance, they are not just looking for the theta here, right? So we will just have to substitute it back, yeah. Okay, so the x is actually r cos theta. Sorry, we are looking at the y, sorry. Y is a r sine theta. Okay, but of course here we have to consider the square root of the 36 cos of the 2 theta sine pi over 6. So this gives us square root of the 36 is a 6. Cos pi over 3 is a half, so we get the third of the half. Sine pi over 6 is a half. Okay, so when we tidy this up, we should get a 3 over sec 2. You can leave it in this form, or you want to rationalize it, you actually have 3 sec 2 over 2. Okay, sorry. So you should actually have from here 3 sec 2 over 2. Okay, so that's where we get the answer. Okay. So we have actually looked at like 5 questions, okay, from the polar, which is about the differentiation and also the integration part, which I think a lot of the students are not so confident with. Okay, so the key thing is to really work on our integration, right? Okay, so that's the end of the video. If you find this video is helpful, please share with your friends, with your classmates. And if you would like to subscribe to this video, please do so, because it will really help me to produce more videos. Okay, and if you have any suggestion on what are the topics that you want to look at, please do also comment in the comment section below. Thank you so much, and I'll see you in the next video. Bye.